All right, now let's talk a bit about constitutional isomers. And you may remember our example of constitutional isomers. So, for example, we could compare cis 1,2-dichloroethylene versus the 1,1-dichloro. Okay, so the same empirical formula, C2H2Cl2, but different connectivity. And so that's how all of our different constitutional isomers will work. Well, we have four prominent classes of these constitutional isomers in inorganic chemistry. The first one we'll talk about are hydrate isomers. Now, this hydrate, so a lot of these complexes are made in water. Water is the solvent, and so water can be hanging around acting as a ligand and also doing other things in the coordination. And so it was found that there were three complexes that had the formula CrCl3 dot 3H dot 6H2O. But you could get a violet, a blue-green, and a dark green complex out of that. Well, let's now knowing what Werner knew, let's draw the structures for these. So it ends up that the violet complex looks like this. Okay, and we're being good chemists. We're making sure to always attach the oxygen to the Cr. The chromium has a +3 oxidation state. And so the complex cation is +3 overall because the water's neutral. And there are 3 chlorides hanging around as counterions. And this is the violet compound of the 3 that was made. Next, there's a compound that is blue-green that has a chloride. We'll say there on the top. It has 5 water molecules attached, so it's still chromium 3 plus. But now this is got a chloride within the coordination sphere, and so the complex cation has a +2 charge. So I need 2 chlorides outside to balance the charge. And this ends up having, when it forms a crystal, it holds in a water of crystallization. You may remember hydrate compounds, and this holds on to a water of crystallization, exactly 1. And so these two have the same empirical formula. They both, in the crystalline form, have 6 waters, 3 chlorides, and a chromium. Okay, and in this particular case, there was one more that was synthesized. There is and this is the trans geometry. There's a chromium with trans chlorides. It has the rest of the sites filled with water. So it has 4 waters, 2 chlorides. Chloride is a -1 ligand. It's still chromium 3. And so the complex cation has a +1 charge. There is a chloride hanging around on the outside as a counterion. And there just happens to be, when this crystallizes, there's 2 waters of crystallization that form in this crystal structure. And this is the dark green crystal. Okay, all 3 of these having the exact same empirical formula, so these are structural isomers. They have the same empirical formula, but have different things bound to the chromium center.